What is the best way to configure interrupt controller registers? Imagine you're trying to catch a ball, and you want to be ready the moment it comes your way. In embedded systems and microcontrollers, configuring interrupt controller registers is like setting up your glove to catch those incoming signals perfectly. It might sound complicated, but once you understand the steps, it becomes straightforward. First, always start by disabling all interrupts before making any changes. This prevents the system from reacting to incomplete setups, which could cause errors. Usually, this is done by clearing a global interrupt enable bit in the control register. Next, look at the hardware peripheral that will generate the interrupt. For example, if you're setting up an external button press, configure the pin as an input and set up pull-up or pull-down resistors to stabilize the signal. Then connect the peripheral to the interrupt controller. On some microcontrollers, this involves mapping a specific pin or device to an interrupt line through configuration registers. Make sure the clock for that peripheral is turned on, or else the registers might not respond. Now, set the trigger condition for the interrupt. You can choose rising edge, falling edge, both edges, or level change, depending on what the hardware needs. This is done in the interrupt configuration register. Before enabling the interrupt, check if any flags are set from previous events. Clear these flags by writing a 1 to the flag bits. This step prevents the system from immediately jumping to an interrupt service routine after setup. Once the flags are cleared, enable the specific interrupt in the interrupt enable register. If your microcontroller supports setting priorities, assign a level to this interrupt. Higher priority interrupts will be handled first if multiple happen at once. Finally, re-enable global interrupts to allow the processor to respond to events. Always double-check your microcontroller's datasheet for exact register names and bit positions, because different chips have different setups. Following these steps ensures your system responds reliably and predictably to hardware signals. Proper configuration of interrupt controller registers is key to making embedded systems work smoothly and efficiently.